Rogers, you had a chance to fly the SR-71 Blackbird, the very mythical aircraft. And in fact, as I recall from our previous discussion, you were the last pilot to ever fly one. And that was, I think, in the early to mid-90s, somewhere, later 90s?
So late 90s.
Late 90s,
99.
okay. So by then, this aircraft was pretty mature. A lot of folks had flown it, guessing all the pubs and restrictions and all that were well known. Was it easy? Was it an uneventful aircraft to fly in the late 90s?
So the SR to me was a magical and mystical airplane as it is to many people. But in terms of flying it, you had a checklist, you had a handbook. We had help from the people that had done it in the Air Force to tell us what was really important and what wasn't.
Because you were flying it for NASA.
We were flying at NASA, and we flew from 91. I flew 91 to 99, 1999 at NASA. So it was never routine because the corridors that you had to keep the airplane in and the condition you had to keep certain things in the cockpit and in particular in the ducts, in the engine inlets, were critical. And so you had a lot of respect for the criticality, but you followed the checklist. You could fly the airplane, hand fly it. It was not difficult to fly. You followed it, and it generally did exactly what. But when it did not, so your level of concentration, I can say it's pretty high, night refueling in an F-16, let's say, but nothing like the average in this airplane because you had to be paying attention. So in one case, we were going to take some data that people, our engineers, wanted for the inlet doors, the forward inlet doors and the aft doors were part of the magical and the spike system that allowed a turbojet to become a ramjet, which was twice as efficient as a ramjet as it was back down at 30,000 feet as a turbojet. So we were to move now out of the auto position, it's like a rheostat up here, on one of the ducts, move it from where it wanted to sit, where we were at about 75,000 feet at Mach 3, maybe a little higher. And we were to move it an increment, like from 40 down to 20 and back to auto. We practiced it in the simulator, except that for reasons that I don't understand, there were two detents, one at auto at the top, so the rheostat would go into a detent, and one at 100% just before it. So I practiced it and so on, but touching the forward doors, which are always run by the computer, in the real place up there was a little, not anxiety, but you want to get this done quickly, which I did, make the incremental change and moved it back, but I got the first detent in 100%. Doesn't want to be at 100%. So instantly that it was there at 100% for a few seconds, now a machine gun went off somewhere in this airplane, the worst compressor stall you ever imagined. And we are up at 75,000 feet at Mach 3. And now it goes into, it on-starts, or one of them, because the other inlet has to go into sympathetic on-start even when it's running properly in order to keep the yawing forces balanced, because it's not a very strong airplane up there when it's hot. So now the cockpit gauges are all moving. This machine gun is going off. What do? Well, I start the throttle back. Out of burner, we're going to slow down. I come back, and it stops. I've achieved the first thing, and then I look. We are noses down a bit. You might not understand, but it's amazing. The airplane, the maximum speed in the SR-71 in indicated airspeed is 500 knots. We typically flew like 450 knots indicated, but at 85 or 70 to 85,000 feet, that translates to 2,300 miles an hour. So all the gauges are moving, and it's quiet now, but we're starting downhill. We're at 490, and I know I got to get to 500, keep it below 500. And so I do that, and now the airplane starts rolling. We're descending, and I'm telling the guy in the back to clear, our backseater, declare an emergency, tell us FAA we're coming down. So once we get above 60, they're not worried about us. So now we're going to get below 60, and there could be airliners underneath us. So we do all that, and it's rolling, and that's uncommanded, and I'm starting to worry about ejecting and thinking. But I'm thinking all the time, and I don't like the idea of ejecting at 70,000 feet. So anyway, we finally come down and level off, and at 30,000 feet, and we push the throttles up and everything's back to normal. I tell my backseater to tell the FAA to cancel the emergency, which we did and flew back. But that was caused by me. But it's a fragile corridor. But a major point is I was proficient generally in flying all the time, and I was still thinking. Now, I made the mistake. But I could still think the whole time. And that's an important thing that you need to be able to, what are you going to do faced with the unexpected in your car, in your airplane, where, and you have to practice in order to be able to do that. So practice makes permanent.
Even in that case, though, isn't there, not to say you didn't own the mistake, but isn't there some degree of interface that maybe could have been better by not having those two detents so close to each other?
Course.
And that's some of the feedback I would think of a test pilot. Even in an aircraft that's just about ready to be ushered out, a legend like the SR-71, there's always better interfaces between man and machine.
That's absolutely what your goal is as a test pilot. It's a discovery process, research or testing, but you're trying to discover, and it's more difficult today than it ever was. Now we have AI and other things. We have people that are running organizations that are Harvard business graduates, not technical people. They hire technical people.
The SR-71, that wasn't your last flight, but was it also not your last emergency? Didn't you have something with some fuel issue at one point?
Yes, we did have, we didn't take the airplane, we took it away from Edwards, but we usually did training either to the south down along the Mexican border or up to the Canadian border. We'd do a training flight, and we'd refuel with the tanker, Edwards tanker. Finally, they have special fuel in the SR, non-volatile fuel. You could throw a match on the ground, it wouldn't ignite. So it's important to the story is that they have to inject TEB, special compound.
TEB?
TEB, TEB is a short, triethylborane, I think it's called. It ignites spontaneously in the presence of air. So that's a difficult design problem. You keep enough for like 12 shots. Every time you start the engines, every time you light the afterburner, it puts a shot of TEB in that ignites the fuel, and then it sustains it. So we were we were invited to go to Oshkosh, take the airplane to Oshkosh, fly by at Oshkosh, and fly back to Edwards, not landing there. So our tanker was going to meet us, the Edwards tanker, with our crew chief in it and so on, they refueled us all the time. And we had an F-18 that we sent there at the invitation of just to have it on static display, nice paint job. And so I was the chief pilot, so I called the pilot and said, why don't you fly that day and meet us up over the lake with the tanker, just to do something there. So we did that, and we got there. I mean, we flight planned it, we talked to everybody. We entered Chicago airspace at Mach 2.5, descending. We had it all figured out what we were doing. Then we'd make the passes, and then we come back up over the lake and meet the tanker. We're on the tanker getting gas to go back to Edwards. The backseater's getting flight plans, and we're going to climb out and go supersonic over high up, but maybe 45,000 feet, over Oshkosh. And so it's busy in there, and now the F-18, one of our pilots, is on the right wing. The boomer is saying to us, hey, there's a lot of fluid coming out of your left exhaust. I'd never seen it before. It's like, so we're going, well, wait a minute, we're talking. Finally, I say to the F-18 pilot, why don't you come around to the left side and tell me what you see? So he does, and he said, whoa, there's a lot of fluid pouring out of your left exhaust. What it was in the SR, they don't have hydraulics for the feathers, for the afterburner, the exhaust opens up. They use fuel, the fuel that's non-volatile. They have a small pump that makes the pressure up to 3,000 psi to actuate the feathers. So what we're pouring out back there, I don't know what it is, but it was fuel. And so this pump has a small line that goes back to the actuator and so on. And so as soon as he says he sees this fluid coming out, I say, okay, we're declaring an emergency. We're going to land in, we're going to Milwaukee. So we now declare an emergency, and we got an F-18, and we got the tanker. And the backseater is moaning a little. I say, read the checklist to me, and he says, shut down the left engine. And I'm going, okay, we're going to shut down. He said, oh. So we talked about that. Meantime, we got down to about 20,000 feet. And people told us later, I could see you were conning down there. We weren't conning. It was fuel pissing out. So we get on final, and I tell the tower what we're going to do. The tankers, the F-18 is going to land, get off the runway, and the tanker's going to land after or something. So he says to me, I don't understand what you said, but whatever you want to do, you can do. So what had happened was this little pump became eccentric. Something failed in it, and it was shaking. So it broke the line. So the 3,000 PSI fuel was pissing out there. I'm not sure what would have happened if we'd ignited the burner. I think it might have been a minor explosion there. Certainly it would be a big fire because it would be way more fuel. So that was an interesting emergency. And the airplane, there's a guard base and a reserve base. And so they took care of us. They got an engine and all the people. They did a training flight, brought it all. A week later, another crew came out and brought the airplane home with another engine. So that was pretty exciting stuff in the magical airplane.